Hey there, everyone. Welcome back to the Print Talk. Great to have you with us. How's everything on your end, Kenneth?
All good here, Neil. Excited to dig in. What's the focus for today?
Today, we're taking a deep dive into something that's probably caused many of you some frustration.
Yeah.
We're talking about 3D printer stringing.
Stringing?
You know, those little cobwebs or hairs that just show up on your prints? We're going to figure out how to get rid of them.
It's a pretty common problem. You know, it happens in the world of FDM printing. Basically what happens is you have a molten plastic, and it's oozing out of the nozzle when it's moving between printing points. So it's almost as if your printer is leaving like a trail of breadcrumbs, but not the kind you want to eat.
Definitely what we want on our masterpieces.
You know.
So how do we stop this filament from just going all over the place? Is it all not that retraction thing I keep hearing about?
Yeah, retraction is definitely the first line of defense. It's basically just telling the printer to pull back the filament just a tiny bit every time the nozzle is going to move without extruding. It's kind of like if you were using a pen, you had to lift it off the paper, you would retract the pen tip a little bit to stop the ink from flowing.
Okay, yeah, that makes sense. But how do you know how much to retract it? I mean, is there like a magic number?
Unfortunately, there's no magic number. The best settings for retraction are going to depend on a few factors, like the type of extruder you have. So, for instance, if you have a Bowden extruder where the filament has to travel a longer path to get to the nozzle, you'll probably need to use a longer retraction distance than if you have a direct extruder.
Okay, so a Bowden extruder is kind of like the filament having a long commute.
Right.
And a direct extruder is more like working from home. It doesn't have to travel as far.
Yeah, exactly. And then also, the type of filament you're using can make a difference too. So some filaments, like flexible filaments, are just naturally more prone to oozing. So you might need to adjust your retraction settings accordingly.
So you're saying you can't just set it and forget it?
No. Experimentation is always key, especially when you're first starting out or if you're trying a new filament. Luckily, you can use a test print to really dial in those settings and see what's going to give you the best results.
Test prints. Always a good idea.
Yeah.
Now, my slicer also has some, I guess, fancier features. Things like coast and wipe.
Yeah.
Do those play into retraction at all?
Yeah, they do. They're kind of like advanced retraction settings. So coasting is basically when the printer stops extruding filament a little bit before the end of the line to relieve pressure and prevent oozing. And then wiping is when the nozzle kind of drags along the edge of the print to, well, wipe away any extra filament that might be there.
Okay. So it's all about minimizing that trailing edge that's just begging to turn into a string.
Exactly.
All right. That makes sense. But what about the temperature of the filament itself?
Right.
Does that have anything to do with stringing?
Oh, temperature is huge. Absolutely. Because you see, as the filament heats up, its viscosity changes. So the hotter it gets, the more it behaves like, I guess, a thin liquid.
Right.
So the more likely it is to ooze out of the nozzle, even if you have retraction enabled.
Gotcha. Okay, so hotter filament equals more oozing. Simple enough. So should I just like crank down the temperature to avoid the stringing altogether?
Not so fast. After a number, we do need the filament to melt properly for extrusion. So if you lower the temperature too much, you could actually run into other problems like under extrusion or even clogging in the nozzle. It's really about finding that sweet spot that's not too hot, not too cold, but just right for a nice, smooth flow.
So it sounds like temperature is another setting that needs a bit of fine tuning. Any tips on how to find that Goldilocks zone?
Well, I would always recommend starting by checking the recommendations from the filament manufacturer. They'll usually have like a temperature range that they recommend for optimal printing, but it's important to remember that every printer is a little bit different, so you might still need to do some experimentation.
Okay, so we're back to those test prints. Are there more systematic ways to figure this out?
Yeah, absolutely. You can try a temperature calibration tower.
Oh, yeah.
It's a special kind of test print that basically lets you test a whole bunch of different temperatures all at once. So as the tower prints, the temperature gradually changes, and you can just look at the results and see which temperature looks the best, which one gives you nice, clean lines and the fewest strings.
Right, so you can just look at it. You don't have to mess with the numbers as much.
Exactly.
Perfect. So we've covered retraction and temperature, two of the big players in this stringing game. But something tells me there's even more to the story. What else should we be thinking about?
Right.
Okay, so we've tackled retraction and temperature. Those seem like pretty big factors when it comes to stringing, but I'm sure there's more, right? What other things can cause those pesky strings?
Yeah, so think about it this way. The faster your nozzle moves around, the less time that molten plastic has to just kind of hang out and drip.
Right.
So the print speed, specifically the travel speed, that's the speed the nozzle moves between those actual printing points.
Okay.
That could also have a big impact on stringing.
So are we saying faster is always better when it comes to travel speed? Just crank it up and goodbye strings.
Well, not quite. It's all about finding that balance.
Oh,
If you push the travel speed too high, you might end up with other problems.
I see.
Like under extrusion,
Okay.
where there's just not enough filament being laid down.
Right.
Or even layer shifting, where the layers of your prints start to misalign.
Oh, yeah. We don't want that.
No.
So just like with temperature, there's a sweet spot for travel speed too.
Exactly. A good starting point is usually somewhere around 150 to 200 millimeters per second. But you really do want to experiment to see what works best for your particular printer and, of course, the filament that you're using.
Experimentation. Okay.
And
So more test prints, I imagine.
always test prints, yeah? Yeah.
All right. Well, that makes sense. So, okay, you know what? Let's take a step back from all these settings for a minute.
But then,
Is there anything we can do with the physical printer itself?
yeah.
Keep things clean and
Yep.
hopefully string-free.
Okay. You're thinking like a true 3D printing pro now. Sometimes, honestly, the simplest solutions can be the most effective.
Right.
And when it comes to preventing stringing, a clean nozzle is really super important.
Right. So we're talking like basic hygiene, a little soap and water.
Not quite soap and water,
Mhm.
but close. Even just those little tiny bits of filament, especially from materials like PTG, they can build up on the tip of your nozzle,
Okay.
and it creates this kind of rough surface that the molten filament just loves to cling to.
Okay, so how do you actually clean it then? Like, what's the best way to do that?
Well, while the nozzle's still hot, you can very carefully wipe down the outside with a clean cloth, maybe with a brass brush,
Okay.
just to get rid of any gunk that's on the exterior. For the inside, you can use a small needle,
Okay.
or there are also these specialized creaming filaments, and they can really help to kind of clear out any blockages.
Oh, okay, cool. What if, like, the cleaning just isn't enough to get rid of some really stubborn residue?
Well, in that case, you can try something called a cold pull. You basically use a special cleaning filament to kind of pull out any of that stubborn gunk from the nozzle.
Oh, okay.
And, if all else fails, you might just have to replace the nozzle altogether.
Gotcha. All right. So a clean nozzle, happy printer, and hopefully a string-free print.
Right.
But before we wrap things up, I think there's one more kind of sneaky culprit that we need to talk about.
Yeah.
Moisture.
Yes. Moisture. It's a silent saboteur of filament.
It really is.
A lot of filaments, especially PLA, they are hygroscopic, which means they absorb moisture from the air.
Right.
And when that moisture-laden filament gets heated up in the nozzle, whoa,
Boom. It turns into steam, and then you get all those tiny bubbles in the molten plastic, and it's just like makes it so much more prone to oozing and stringing.
right.
I've heard horror stories about PLA turning into a gooey mess just from sitting out in humid conditions.
Yeah, that's exactly what happens. So proper filament storage is absolute crucial. You want to invest in some airtight containers, put some desiccant packs in there, keep that moisture out. And if you think that your filament has already absorbed some moisture, you can actually dry it out using a filament dryer or, in some cases, a carefully monitored oven.
Okay, good to know.
Mhm.
I've definitely had some prints go sideways because of, I think, moisture in the filament.
Mhm.
So we've covered a lot of ground here, haven't we?
We have.
I mean, we've talked about retraction, temperature, speed,
Hmm.
nozzle cleanliness, even how important it is to keep our filament dry.
Mhm.
It's amazing to me how many different things can affect those little strings.
It really is. But now you have all this knowledge. You're well on your way to getting rid of stringing for good. And, you can create those beautiful cream prints that you've always wanted.
I'm feeling pretty confident already.
Yeah.
So any final words of wisdom before we send our listeners off to their, hopefully, from now on, string-free printing adventures? So we've really dug deep into this whole 3D printer stringing thing. And I feel like we've given everyone listening a whole bunch of tools to fight those annoying strings.
Yeah, for sure. We covered a lot of ground.
I mean, we started with the basics like retraction and temperature, but then we got into some of the finer points like travel speed, keeping that nozzle clean, and even how important it is to make sure our filament is dry.
It's pretty amazing how many different factors can affect stringing, isn't it?
It really is. But now that we know what to watch out for, we can, approach those stringing challenges with a lot more confidence. Like, we're not at the mercy of these random strings anymore. We can actually understand what causes them and, try to prevent them.
Absolutely. And the best part is this is just the beginning. every single time you try a new filament or a new print that's particularly challenging, or even just make some little adjustments to your printer, it's a chance to learn something new, to refine your skills. The more you experiment, the better you'll understand how all these different factors, kind of work together to affect the quality of your prints.
It's really all about experimenting, isn't it?
Yeah.
And not being afraid to, tweak those settings, try different approaches, just push the boundaries of what you can do with your printer.
Exactly. And who knows, maybe you'll even stumble across some amazing new technique, a workaround, something that we didn't even mention here today, something totally new.
That's what I love about 3D printing, right? It's like this ever-changing world. And it's driven by this incredible community of makers who love to share what they've discovered.
Exactly.
Go out there and create those amazing string-free masterpieces. And if you find some cool new way to get rid of stringing, let everyone know. Share it with the community.
Exactly. We're all in this together, right?
We are. We're united by our love of making things, and the excitement of taking something that's just a digital design and turning it into something real.
That's it. Happy printing, everyone.
Thank you, Kenneth, for all the great insights today.
Absolutely. Thanks for having me. It's always a pleasure diving deep into these topics with you.
The pleasure's all mine. All right, everyone, until next time, stay curious and keep creating.